Hello Year 6 and welcome to Friday's maths lesson. Happy Friday, we made it through another week. You have done an amazing job with your maths this week. We've had some really tricky maths and you've persevered and stuck at it, and I'm really proud of each and every one of you. I've absolutely loved seeing you work and seeing how hard you're working. So much working out I've seen this week. You are absolute superstars. It's really hard at home and you're doing a brilliant job. So today we are carrying on with algebra. Now, before we get started though, we are going to do a couple of things to warm our brains up and remind us of a couple of things that might help us today. So the first thing is factors. Now remember, a factor is two numbers that can be multiplied together to get another number. And it's numbers that a number can be divided by without a remainder. So if I think about 12, so the factors of 12, this is how I would do it. This might remind you. So if I start on 1, would be 1 and 12. Okay, so that 1 and 12 are factors of 12. 1 multiplied by 12 is 12. So I'd go through and see if there's one that goes with 2, 3, 4, 5, 6, and so on. So you've got to find the factors of both 12 and 18 and then see if there are any common ones. So that means that factors that both 12 and 18 have got. So we'll start with that one to warm our brains up. So you can pause the video and have a go at that one. Okay, so we'll have a look at it together. So we've got 2 and 6, you should have 3 and 4. Can't do one for 5. It's not in the 5s. Can't do one for 6. Oh, we've already got 6. Can't do one for 7. Can't do one for 8. Can't do one for 9. Can't do one for 10, 11. And we've already got 12. So I'll do 18 there. So I've got 1 and 18, 2 and 9, 3 and 6, can't do 7, can't do 8, already got 9, can't do 10, can't do 11, can't do 12. So now I need to see the common ones. So they've both got 1, they've both got 2, they've both got 3, and they've both got 6. So they are the common factors of 12 and 18. So I've got one more thing to warm your brain up today and to remind you of, and that is square and cube numbers. So a square number, so that's when you see something like this, 3 and then a little 2 next to it, is a number multiplied by itself. So for example, 2 squared would be 2 times 2. So that would be 4. Okay? And then cubed then is when, so if I write that to remind you, so it's a number multiplied by itself. Cubed then is a number multiplied by itself and then again. So on this one, 2 cubed would be 2 times 2 times 2. Okay, so I want you to pause the video now and have a go at those. You have to match them to the correct answer. So if you don't get one of these answers, you know you've made a mistake. So pause the video now and have a go at that one. Right, so let's have a look together then. So 3 times 3, so that would be 9. 2 times 2 times 2, so 2 times 2 is 4, times by 2 is 8. Then you've got 8 squared, so that would be 8 times 8. So 8 times 8 is 64. Then you've got 12 squared, so that would be 12 times 12, which is 144. And then you've got 5 cubed, which is 5 times 5, which is 25, times by 5 again. So that would be 125. So hopefully that's got our brains nice and warmed up this morning before we move on to our algebra. So today then, we are carrying on with solving algebraic equations. So we're going a little bit further and a little bit deeper today. So the first question then, I've done one really similar here to help you. So I think what we'll do is I'll do this one together with you and then you can have a look at your book and do that one. So today we are looking at page 27 in our workbook, and it is another algebra page, as I said. Now the first section is really similar to some of the work that we did yesterday. So I'm going to leave that one for you to get on with, because I know you'll be fine with that from seeing your work from yesterday. So the ones I want to go through then. So I've done a question, so it's still on algebraic equations. So I've done a question really similar to the one that you've got in your book to help you to work it out. So you've got Sam is training for a race. Each day he runs 1.5 kilometres further than the day before. So every day he runs 1.5 kilometres more. On the first day he runs 1 kilometre. How far will he run on the 5th day of his training? So the best way to work a question like this out is by using a table. So on the first day, it said that he ran 1 kilometre, so I'm going to put that in. And then every day, he runs 1 kilometre more than the day before. So on the second day, he'll run 1 kilometre plus 1.5 kilometres. So that would be 2.5 kilometres. Okay, so then the next day, he runs another 1.5 kilometres than the day before. So that would be, so the other 5 would take it up to 3. So it would be 4 kilometres. Okay, so then the next day, so look at the top here, I've put the day. So day 1, day 2, day 3, day 4. And I've got to work out what he runs on day 5. So then it would be 5.5 kilometres. And then it would be 7 kilometres. Okay, so on day 5, because that's the day that I've been asked to work out, he would run 7 kilometres. Okay, so that's really similar to the question that you have got, but you've also got a couple of extra questions. So really similar, you've just got different numbers. Then you've got to work out, so the 7th day, then the 12th day, and then which day would she run 5.5 kilometres. So when you have done your table, you'll be able to see which day she runs that amount. So use a table for that one, just like the one I have done here. So you might want to pause it. So you've got different numbers, so don't copy my numbers. All you need is the day and how far they have run, and then add it on each time. So, and then that will help you answer the other questions. So you might want to pause it now while that's fresh in your mind and go on to that one. Okay, so the next bit that I want to look at with you. This is really similar to the next section in your book. I've just used different numbers so that when you can apply it to your questions. So some children and adults go on a boat ride. In total, there are 18 passengers and there are more adults than children. So there are 18 passengers in total, but there are more adults than there are children. So this one then, you've got to find 3 possible pairs of numbers for the number of children and adults on the boat. So this one is a bit of what we call trial and error. So you try different combinations. So I'm going to try some different combinations of numbers. So I will do one, then I'm going to ask you to pause the video and have a little go yourself. So if I had 9 adults, then there would also be 9 children. So that one, that wouldn't work, would it? I'd have to try something else because I've got to have more adults than children. So let's try something else. So this time I'm going to have 10 adults. So if I've got 10 adults, I would have 8 children. So that one would work because I've got more adults than children. So I want you to pause the video now and see if you can think of a combination where there are more adults than children, but it's got to add up to 18. So have a pause and see if you can think of one now. Okay, so did you have a go? So you could have, if you had 11 adults, then you'd have, so 11, you'd have 7 children. So that one would work. And you could have 12 adults and 6 children. You could have 13 adults and 5 children, as long as there's more adults than children and it adds up to 18. So that will help you with the next one in your book. So you might want to pause it and do number 3 now. Right, so you might have a go at number 3. You might want to watch the whole video and then have a go. So then the next one I want to look at, so again, this is really similar, just with different numbers. So the formula, so a formula just means an equation, a sentence that any numbers can go in. So it might be with letters, it might be with words. So the number of chocolate chips in a Chocolux cookie is the weight. So you've got the weight divided by the length, take away the width. Now, because that's in brackets, we've got to do that first. So the first thing we have to do is the length, take away the width, and then the weight divided by whatever answer we get here. Now, that's a formula because we could put any numbers in here, any at all, okay? So a cookie is 8 centimetres long. So straight away, I'm going to put 8 centimetres to tell me that, and 6 centimetres wide, and weighs 40 grams. So that will help me to work out how many chocolate chips will be in the cookie. So remember I said that we need to do the bit in brackets first. So we need to do 8 take away 6, which is 2. So then I can do 40 divided by 2. 40 divided by 2, which is 20. So that means there will be 20 chocolate chips in the cookie. So that one will help you with that one that is next. So then finally then, we're going to do a couple of these ones together to help you with your last bit. So this is a formula then. Remember I said it's got letters instead of numbers. So these letters can mean any number as long as y multiplied by z is 24. So it could be a couple of different numbers. So that's where your factors come in. So your factors of 24 are really going to help you. So I'm going to give you one. So I'm going to give you that y could be 2 and z could be 12 because that is 24. So now I want you to pause the video, and in your purple book, I want you to think of 2 different ones for Z, for Y, and 2 different ones for Z. Remember that when you multiply them together, they've got to equal 24. Right, so you should have had a go of that. So you could have had 6 times 4. So Y could be 6, Z could be 4, because 6 times 4 is 24. Okay, you could have had 8 multiplied by 3 is 24. Okay, so Y could be 8 and Z could be 3. So you could have had different combinations. Any of the factors of 24, you could have had 1 and 24 is 24. Okay, so there's quite a few you could have had there. So those letters can mean anything. So I'm going to give you another one to have a go at. So this one is y times z is 18. So your factors from the beginning of the lesson should really help you here. So pause the video now. What possible numbers could be y and what possible numbers could be z? Okay, so let's have a look at it together. So you could have had 1 and 18. So y could be 1, z could be 18. You could have had 2 and 9. So y could be 2, z could be 9. You could have had 3 and 6. Y could be 3 and z could be 6. So that will help you with the very last question today. You've got something very similar on your last question with y and z. I was really impressed with your algebra work from yesterday. So keep it up. Looking forward to seeing your work, and happy Friday again.